Students, all of you, good evening. Welcome to the session. Continuation of circuit theory, that is network theory concepts. With respect to chapter 1, that is fundamentals of electrical circuits. I'm starting lecture 6. In this session, mainly how to concentrate what are the energy calculations in RLC elements. That is, if resistor is given, how to calculate the energy in resistive elements, how to calculate the energy in inductive elements, capacitive elements. Combination of RL is given, RC is given, then how to calculate the energy. This is one of the most important 5-star concept for any competitive exam point of view. Already questions are framed in different competitive exams based on this topic. Yes, friends. Before solving different models of questions with respect to energy calculations in RLC elements, this you have to concentrate some minimum knowledge. This minimum knowledge is required to solve the different models of questions with respect to energy calculation. One is, students, we know that what is the energy stored by the inductor? Energy stored by inductor. The energy stored by inductor is, that is EL equal to half Li square. This formula, all of you, is the formula for energy stored by the inductor. We know that inductor stores the energy in the form of magnetic field. Inductor stores the energy. Inductor stores the energy in the form of magnetic field. Form of magnetic field. Form of magnetic field. Okay. And one more point you have to remember: if di by dt equal to 0, if there is no rate of change of current, that is, with respect to time, the current is constant, then what is the energy stored by the inductor? The energy stored by the inductor equal to 0. If it is a constant current, students, we know that V equal to L into di by dt. If there is no rate of change of current, then the energy stored by the inductor equal to 0. Next. These observations are important to solve the different models of questions. What are the energy stored by capacitor? Energy stored by capacitor. Energy stored by capacitor. That is EC equal to half CV square. This is the formula for energy stored by the capacitor. Then capacitor stores the energy. Capacitor stores the energy in the form of electric field. The form of electric field. Yes, friends. Even in capacitor also, if there is no rate of change of voltage, if dV by dt equal to 0, the energy stored by the capacitor is 0. The energy stored by the capacitor is also 0. If dV by dt equals 0, energy stored by the capacitor is also 0. Next. What is the power dissipated by resistor? How much power is dissipated in the resistor? The power dissipated by resistor equal to, or energy dissipated by resistor. Calculating energy dissipated. So power dissipated, you have to calculate energy dissipated by resistor. Energy dissipated by resistor. The energy dissipated by resistor equal to I square R into T. How to apply? Or you can also apply V square by R into T. V square by R into T. So this important formulas you have to concentrate. And one more important observation, friends. Throughout solving of the problems based on this topic, one of the most important waveform it will repeat. For this, I'm not giving derivation. Later on in the AC analysis, I will give the derivation. If it is a triangular waveform like this, let the amplitude is A. For this waveform, amplitude is A. Yes. If it is amplitude is A, then what the average of this waveform? Directly remember, these waveforms, how we can calculate average and RMS values. That concept I will discuss in the AC analysis. Up to now, you remember, average is A by 2. What is the RMS of this waveform? A by root. RMS of this waveform is A by root. If it is a constant waveform, students, if it is a constant waveform like this, if it is a constant current waveform, it is given, let the amplitude equal to A. For this case, what is the average? Average is equal to A. Then what is the RMS value of this waveform? Is also A. That is for pure DC, average is equal to RMS, then form factor is unity. Clear? This average is equal to A, then RMS is also for is a constant wave. So many other waveforms also there, but for those waveforms, I will discuss in the AC analysis. But in solving of the problems, this is very important. Okay. in calculation of energy calculation in RLC elements. This is I can start with the first example. See, for example, if it is given like this. So this is the resistive element. Let only resistance is given. Only resistance is given. Let the current is I. The value of resistance is 10 volts. The current waveform, the current characteristics are given like this. These are the current characteristics. This current is allowed through this resistance. Let this is the current characteristics. This is the current characteristics. For these characteristics, you have to calculate what is the energy dissipated by the resistor. This is given to, this is 4, and this current value is given is 4 amperes. It's a 4 amperes. Let this is the T. Then you have to calculate, find energy dissipated in resistor. Find energy dissipated in resistor. Energy dissipated in resistor. For 0 to 4 seconds. For 0 to 4 seconds. How to calculate what the energy dissipated by resistor for 0 to 4 seconds. Friends, here I have to give two methods. Method 1 is as for the concept. Method 2 is directly how to write. In objective point of view, method 2 you have to follow. Descriptive, who are preparing for ESC descriptive point of view, method 1 you have to follow. Then how to answer this one, friends? How to calculate what is the energy dissipated by resistor for 0 to 4 seconds. Here, during this 0 to 2 seconds, 0 to 2 seconds, this is 0 to 2 seconds. Now. Let the energy dissipated by resistor is ER1. Let 2 to 4 seconds, the energy dissipated by resistor is ER2. Then total energy dissipated by resistor equal to E equal to ER1 plus ER. ER1 plus ER. Okay. Then how to write the energy dissipated? This is equal to integral 0 to 2 I square R dt plus integral 2 to 4 I square R dt. Now for 0 to 2 seconds, you have to find what the equation of this curve. It's very simple. For 0 to 2 seconds, for 0 to 2 seconds, it is a line passing through horizon y equal to mx. How to apply y equal to mx. On y-axis, what you taken correct? I equal to slope 4 by 2 students, 4 by 2. In x-axis, what you taken t. Okay, this first method 1 I am explaining. Method 1. Method 2 directly how you can solve that I will explain. Maximum you try to solve in method 2 in objective point. That is 2t. It is a line is passing through horizon. That's why you are writing y equal to mx directly. But in exam, every time you don't expect this waveform only, this characteristics only. This characteristics may start from this point also. Then in that case, same equation I am finding the line equation also. It is changing from 0, 0 to 0, 0 to in different ways of finding I am explaining. 2, 4. 0, 0 to 2, 4. X coordinate is 2, y coordinate is 4. What are the coordinates here? 2, 4. 2, 4. Then if you are not remembering this formula, and this formula also you have to apply. Y minus y1 equal to, how to find the equations? Y2 minus y1 by x2 minus x1 into x minus x1. On y-axis, what you take on current? I minus, what is y1? This is x1, this is y1, this is x2, this is y2. y1 is 0. What is y2? 4. What is y1? 0. What is x2? 2. What is x1? 0. On x-axis, what you take on time? T minus 0. Then you find this I equal to 2t. Like this also you have to find. Because line is passing through horizon, we can apply I equal to 2t. Like this you have to find y equal to mx. Or using line equation also you have to find. Now you substitute yes. The energy dissipated by resistor equal to integral 0 to 2. What is I you calculated 0 to 2? 2t. That is 2t whole square R into dt plus integral 2 to 4. Integral 2 to 4, it is a constant. This is the constant current. Constant current is how much? 4. 4 square into R into dt. 4 square R into dt. Now you have to integrate and substitute the limits. What you can get? The resistance value is, you have to take common, R is common. This is 4. Integration of t square is t cube by 3. Limits are 0 to 2. Yes, 426.6 watt. Very good. 6 joules. It is energy, na? It's a joules. Thank you. Okay, that is that. Then 16 integration of constant is t. That is 2 to 4. Then you have to substitute E equal to resistance is 10. 4 into 4 by 3. 2 cube minus 0. 16 into 4 minus 2. Now you have to simplify this. How much you get? Then by solving this is 40 by, this is 4 square. No? 4 square is 60. Yes, friends. This is 40 by 3 into 8 plus this is 160 into 2. That is 320. We have to simplify this. Approximately we can get a 426.67 joules. 426.67 joules. This is the answer. This is methods. How to solve this method. If this model is asked in ESC descriptive, you follow like this. But method 2 that I am explaining, method 2, method, directly how you can write. Yes, friends. The total energy dissipated equal to ER1 plus ER2. ER1 plus ER2. Correct? ER1 plus ER2. Now, during this time, 0 to 2 seconds, for 0 to 2 seconds, how to apply E equal to, that is I square R into T for 0 to 2 seconds. 0 to 2 seconds. Plus, this also I square R into T. The energy dissipated formula is I square R into T. No? That is I square R into T. This is 2 to 4 seconds. 2 to 4 seconds. Now, shall I apply like this? For 0 to 2 seconds, it's just like a triangular waveform. No? Triangular waveform. Directly substitute RMS value. What is the RMS value? 4 by root 3. 4 by root 3 whole square. Resistance is how much? 10. 0 to 2 means difference is 2 seconds. 0 to 2, that is for 2 seconds. Into, for 2 to 4 seconds. For 2 to 4 seconds, what the current? Current is constant. How much? 4 amperes. That is 4 square into R is 10. 2 to 4 seconds also difference is 2 seconds. Then what is E equal to? That is 16. 16 by 3 into 10 into 2 plus this is how much? 320. This is correct? 320. This is equal to 320 by 3 plus 320. Are you getting same answer or not? Then what is the energy dissipated? The energy dissipated by resistor equal to 426.67 joules. Are you getting same answer, sir? This method you have to follow. Better to follow this method. Just I square R. You have to substitute. This I is RMS value. This I given I square RT, V square by R into T. Na? These values are, this I told already, these are the RMS values. These are which values? RMS values. Directly you have to substitute the RMS values. Like this you have to proceed. Any doubts, sir? Clear? Better to follow the. For example, if the question is asked in the above problem, yes, friends, in the above problem, important observation, in the above problem, calculate power dissipated by resistor, calculate power dissipated by resistor, power dissipated by resistor, up to infinity, resistor up to infinity, sir, up to infinity. Can anybody? What is the power dissipated by resistor up to infinity? It's very simple. Then what is the power? Not power, energy dissipated. Energy dissipated. I'm calculating energy calculations. Then energy dissipated by resistor up to infinity. Then E equal to ER1 plus ER2 plus ER3. Then E equal to, what is ER1? Integral 0 to 2. What is ER2? Integral 2 to 4. What is ER3? Integral 4 to infinity. This is equal to, yes friends, this is ER1. This is ER2. No need to calculate that. But if you substitute the limits, this we can get infinity. If you substitute the limits, infinity. Then anything plus infinity, infinity joules. The energy dissipated by resistor is, that is continuously, the resistor is dissipate the energy. How much energy is dissipating? Infinite joules. Clear, sir? Yeah, this no need to calculate. Why? Finally, if you add this infinity, then anything plus infinity gives the infinity only. That is infinite joules. Simply remember, friends, by giving the resistor, if it is asked, what is the energy dissipated by the resistor up to infinity, then answer is infinite joules. That is continuously the resistor dissipate the energy. Clear? Okay. This is the model for the resistor. Next, I am solving one more model for inductance. Yes, let this is the inductance. Given is 2 Henry. Given is 2 Henry. Let this is the current I. This is the current I. Okay. And same current waveform it is given. Same current waveform it is given. This is I. This is the current waveform. This is 2 seconds. This is 4 seconds. 2 to 4 seconds now. Then calculate energy stored by inductor. Calculate. This current is how much? It is a 10 amperes. Sorry, it is a 4 amperes. Calculate energy stored by inductor, energy stored by inductor, energy stored by inductor for 0 to 4 seconds. For 0 to 4 seconds. Calculate energy stored by inductor for 0 to 4 seconds. Yes. Here I'm explaining two methods again. Methods. Method 1 and method 2. Method 1 you have to apply for any descriptive answering questions. Method 2 you go for the direct objective part. Then let this is EL1 and this is EL2 students. Then what is the energy stored by the inductor? Here it is asking that calculate energy stored by the inductor. Then energy stored by the inductor equal to EL1 plus EL. Energy stored by the inductor equal to EL1 plus EL2. Then how to calculate EL1? Then EL equal to energy is nothing but a VI into dt, na? Integral 0 to 2 VI dt plus integral 2 to 4 that is VI dt. VI dt. This is the formula for energy. Then shall I write like this? The energy stored by the inductor L equal to integral 0 to 2. How to write V students? L into di by dt. L into di by dt into I into dt. V I am writing V equal to L into di by dt I am writing. Plus integral 2 to 4. What is V equal to? L into di by dt into I into dt. This dt cancel. This dt cancel. Then what is the energy stored by the inductor? Students, energy stored by the inductor L is common integral 0 to 2 I di plus integral 2 to 4 I di. I di. Integral 2 to 4 I di. Better to write like this instead of this. Just a minute. Instead of cancelling that, follow this. Yes, no need to cancel this. Directly you have to write this. Now 0 to 2, what is I, sir? 0 to 2, what is I? 0 to 2, what is I? For 0 to 2, you know that equation. Again, no need to calculate. I equal to 2t. For 2 to 4, what is I? Constant, 4 amperes. This equation I calculated, I equal to. Now I'm calculating di by dt. What is di by dt? D by dt of what is I? 2t. This is equal to 2. 2 to 4, I'm calculating di by dt. What is di by dt? D by dt of constant 4. This is 0. Because it's a constant, 2 to 4 is a constant, there is no change of current. That's why di by dt is 0. Now you substitute all the values. Integral 0 to 2, L is 2 Henry. Di by dt is how much? 2. What is I? 2t into dt plus integral 2 to 4. What is L? 2 Henry. Di by dt is 0. I is 2t dt. Now you tell me. You simplify this energy stored by inductor equal to this is 2 into 2 into 2 8. 8 integral 0 to 2 t dt. But this becomes 0 now. 0 into something that is 0. Then what is the energy stored by the inductor? 8 into t square by 2. Limits are 0 to 2. Now how much energy stored by inductor we can get, sir? How much energy stored by inductor? This I am simplifying. Okay. 8 by 2. 2 square minus 0. No? That is 32 by 2. How much you got? This is equal to 16 joules. Is it correct? Energy stored by the inductor equal to 16 joules. The energy stored by the inductor equal to 16 joules I got. But this is the method. But directly how you can answer? Directly how you can answer? Simple students. Concentrate. Is okay? Yeah. Now see method 2 I am explaining how to calculate the energy stored by the inductor. Method 2. The energy stored by the inductor equal to EL1 plus EL2. I told already, if di by dt is changing, then only energy is storing. If di by dt is not changing, this is energy stored equals. What is the formula for energy stored? Half Li square. Half Li square plus during 2 to 4 seconds. During 2 to 4 seconds, what is di by dt? There is no change of current. Current is constant here. If the current is constant, energy stored by the inductor equal to 0. This is 0. Then EL equal to half into L. How much inductance? 2 Henry. 2 Henry. What the current? How to substitute the current students? Half L is 2 Henry now. L is 2 Henry. Then half Li square. What the current? 4. 4 square. Then how many joules you can get? 16 joules. That is the answer. Again, no need to go for integration, all these. Directly you apply half Li square. By integration only we are getting this formula. By integration, all this energy only we are getting this formula. That's why directly. But here, why this is 0, EL to 0? Because there is no change in current. 2 to 4 seconds. Current is constant. If the current is constant, I told already. If di by dt equal to 0, If di by dt equals 0, what is the energy stored by the inductor? 0. If dv by dt equals 0, what is the energy stored by capacitor? 0. This is very clear. Now, for example, when I'm asking these questions, in the above problem, in the above problem, this one, the above problem, calculate energy stored by the calculate energy stored by inductor, energy stored by inductor, energy stored by inductor up to energy stored by inductor. How to calculate up to infinity? Up to infinity. Calculate energy stored by the inductor up to infinity. Then how we can write, friends? The energy stored by the inductor L equal to ER1 plus ER2 plus ER3. Sorry, EL1 plus EL2 plus EL3, because it's the inductor, you have to take EL1 plus EL2 plus EL3. That is energy stored by the inductor EL1 plus EL2 plus EL3. Then energy stored by inductor equal to integral 0 to 2, 0 to 2, integral 2 to 4, integral 4 to infinity. Now tell the students, the energy stored by the inductor, 0 to 2 already calculated, 0 to 2 already calculated, 16 joules. 2 to 4, it is a 0. Can anybody tell 4 to infinity? Same waveform, it is extended up to infinity, up to infinity. Can anybody tell what is the energy stored from 4 to infinity? 0. Very good. Because up to infinity also current is constant. If the current is constant up to infinity, there is no change of current. Once there is no change of current, then what the energy stored? Equal to 0. Just a minute. Students, wait for 5 minutes. I have a small work. Then I will. Sorry. That is what is the energy stored by the inductor? 4 to infinity, the current is constant. If the current is constant, means there is no change in current. Then di by dt equal to 0. The energy stored by the inductor is 0. That's why totally 16 joules only. See the difference here. The inductor is storing not up, even though it is up to infinity, it is only 16 joules because current is constant. But same problem, once you are solving for resistor, for 4 to infinity, it is dissipating infinite joules. That is continuously the resistor is dissipating. It is not that is current is constant or current is not constant like this. It is not. If the current is flowing, always resistor is dissipating the energy. Yeah, this is important observation. See the one more model, friends. Up to now, I explained only for resistor and inductor. How to see capacitor? If the capacitor is given, how we can proceed? I'm adding the slide. See the example 3. This is the capacitor is given. That capacitance is 2 farad. This is the current I. How to calculate? This is the given waveform. It is given like this. It's given. 0 to 2, 2 to 4, 4 to 6. Okay. And this is the voltage. With respect to capacitor, it is not a current. With respect to capacitor, voltage waveform it is given. It's a voltage waveform. It's not a current, it's a voltage waveform. 2 to 4, 6. This is T. Find the energy stored in a capacitor for 0 to 6 seconds. Find energy stored by a capacitor for 0 to 6 seconds. Okay, then the voltage value is 10 volts for 0 to by a capacitor for 0 to 6 seconds. For 0 to 6 seconds. Yes. Here, no need to explain method. Directly, I'm explaining. Method, you know. Same method. You have to apply method if you want. Instead of VL equal to L into di by dt, IC equal to C into dV by dt, you can. VI, but I you substitute C into dV by dt. Calculate V, differentiate. Yeah, that is the method. Instead of going for method, directly you can write. The direct answer I'm explaining. Tell the students. What is the energy stored by capacitor equal to E equal to EC1 plus EC2 plus EC3. This is EC1 during 0 to 2. 2 to 4 EC2. 4 to 6 EC3. EC1 plus EC2 plus EC3. Yes. This is EC equal to half CV square. Half CV square. EC2. During this time, 2 to 4 seconds, what is the dV by dt? The rate of change of voltage is 0. Then the energy stored by capacitor equal to 0. EC3. EC3 students. EC3 is, this is rising, this is falling. Rising storing the energy, falling releasing the energy. Same energy it will release, minus half CV square. Understand, sir? This is rising characteristics, half CV square means falling characteristics minus half CV square. Then what is the energy stored by the capacitor? Because storing and releasing. If it is asked up to 4 seconds only, your answer is half CV square. But it is asking up to 6 seconds. 4 to 6 seconds, it is releasing characteristics. That's why minus half CV square. Then what is the result? Stored energy equal to? If it is asked, for example, what is the energy stored for 0 in the above problem? In the above problem, what is the energy stored by capacitor? What is energy stored by capacitor? Energy stored by capacitor for 0 to 4 seconds. Can anybody? For 0 to 4 seconds. The energy stored by the capacitor for 0 to 4 seconds, EC1 plus EC2. EC1 is half CV square. EC2 is 0. Half into, what is the capacitance? Capacitance is 2 farad. What is the voltage? 10. 10 square plus 0. What is the answer, sir? What is the energy stored by capacitor for 0 to 4 seconds? Then 100 joule. Is it correct? All of you got, sir? Half CV square now. V is 10. 10 square. 2 to cancel. That is 100 joules. This is for 0 to 4 seconds. 0 to 6 seconds is 0 joules. This is storing. This is releasing. Clear? With this knowledge, now you have to see different models of questions. Before this, one more model that I have to explain for next example 4 students. If RL combination is, this is resistor, this is inductor. This R equal to 2 ohms, L equal to 2 Henry. R equal to 2 ohms, L equal to 2 Henry. Yes. And this is the current waveform it is. This is the current. And this is 2 to 4 seconds. This is 2 seconds and this is 4 seconds. This is T. The current is 10 amperes. 10 ampere. This is I. Calculate energy absorbed by the inductor for 0 to 4 seconds. First question is calculate energy absorbed by the inductor. Energy absorbed by the inductor for 0 to 4 seconds. For 0 to 4 seconds. Energy absorbed by the inductor for 0. Is it asking energy absorbed by the inductor or energy absorbed by the circuit? Same. Energy absorbed by the circuit also. Who absorbs the energy absorbed by the circuit? Energy absorbed by the inductor or energy absorbed by the circuit? Energy absorbed by the circuit. For 0 to 4 seconds. Both are same. But point to remember, students, if it is asking energy absorbed means you have to consider both resistor and inductor, because resistor is absorbing the energy, but it is dissipated. Inductor also absorbing the energy, but it stores. See the statement. Energy absorbed by the inductor or energy absorbed by the circuit. You have to take both elements, resistor and inductor. The B question is asking like this. Energy stored by the inductor or energy stored by the circuit? Energy stored by the inductor. Energy stored by the inductor or energy stored by the circuit. Energy stored by the circuit. Here energy storing means you have to consider only resistor or only inductor, both inductor and resistor. Can anybody? 0 to 4 seconds. Energy absorbed means you have to take resistor and energy store means which is storage element? Only inductor is the storage element. You have to consider only inductor. Only inductor. Clear? Now see, first question answer. Energy absorbed by the circuit or absorbed by the inductor. Energy absorbed by the inductor means resistor also absorbing, because resistor is the part of the inductor. Then ER1 plus, ER2 plus, EL1 plus, EL2. ER1 plus ER2 and EL1 plus EL2. Now what is E equal to? What is ER1? What is ER1? 0 to 2 seconds now. 0 to 2 seconds. This is for 0 to 2 seconds I square R into T. This also 2 to 4 I square R into T. This is EL1, 0 to 2 half Li square. Half Li square. 2 to 4. 2 to 4 is 0. 2 to 4 is 0. I square R into T. 10 by root 3. 10 by root 3 whole square into R is 2 ohms. T is 2 seconds. Plus ER2 I square RT. 10 square because 2 to 4 now. This is 0 to 2. This is 2 to 4. 2 to 4. I square RT. R is 2 ohms. T 2 seconds. EL1 half Li square. Inductor. 0 to 2 both inductor and resistor. If you want, if you have any confusion here, better to write like this. You have to take first ER1 and EL1, next ER2 and EL. That is best without any confusions. If you are confusing, better to write like this. Sorry. Take like this. ER1 plus EL1. ER2 plus EL2. This is for 0 to 2. This is for 2 to 4. 2 to 4. Now, what is E equal to? 0 to 2 I square RT half Li square. 2 to 4 I square RT. 2 to 4 is a constant now. What is EL to 0? I square 10 by root 2 whole square into R. R is 2 ohms. T is 2 seconds. Half L is 2 Henry. I is 10 ampere. Again, don't do 10 by this 10 by root 3. 10 by root 3 because a triangular wave. RMS value of triangular waveform is 10 by root 3. Again, don't do 10 by root 3. Half Li square na directly substitute 10 because after integration only we are getting this. Again, 2 to 4 I is constant na 10 ampere. 10 square R is 2 ohms into 2. Then how much you can get, friends? This 100, 400 by 3 plus 100 plus 400. 500, that is 1500 for 1900 by 3. But the 1900 by 3 is approximately equal to 633.3 joules. Yeah, this is the energy absorbed by the inductor or circuit. Energy absorbed means total elements you have to take, because all the elements, even energy absorbed by the inductor, it is given, it is a practical inductor. Inductor is having some resistance. That's the reason why you have to take the total 633 point. Now, what is the energy stored by the inductor? B question is, what is the B question answer? Energy stored means you have to take only inductors. EL1 and EL2. EL1 and EL2. EL1 plus EL. EL1 is half Li square. EL2 is 0. Half into L is 2 Henry. Current is 10 square. 100 joules. Energy stored by the inductor is 100 joules. Energy absorbed by the circuit. For example, if the question is asked like this. Third question I'm asking. A, B is completed. C, I'm asking one more question. Energy absorbed by the inductor. Absorbed by the inductor. Absorbed by the inductor. Or circuit. Or circuit. For 0 to infinity. For 0 to infinity. Can anybody? It's very simple. What is the answer, sir? Energy absorbed means consists of both resistor and inductor. Resistor and inductor. If the resistor is present, that is ER1 plus ER2 plus ER3 plus EL1 plus EL2 plus EL3, then what ER3 is infinity. This is infinity. But this is 100 joules, already you know. EL1, EL2, no need to, EL1, 100. But this is 0, this is 0. Then anything plus infinity, that is infinite joules. Then what is the energy absorbed by the circuit or inductor? Infinite joules. Because of resistor is present now. If the resistor is present, up to infinity means that is infinite joules. Up to infinity means infinite joules. Again, no need to solve this. I'm asking one more question. Energy stored by the inductor. Energy stored by the inductor. Stored by the inductor or circuit. Stored by the inductor or circuit. Energy stored by the inductor or circuit. Energy stored by the inductor or circuit. Then what is E equal to? Energy stored by the inductor or circuit. Then storing means you have to take only inductor. EL1 plus EL2 circuit for 0 to infinity. For 0 to infinity. Only storing energy means you don't get any infinity. EL1 plus EL2 plus EL3. This is 100 joules, EL1. And this is 0. This is 0 because it's a constant now. Up to infinity, you see this one. This is a constant. If it is a constant, it is a 0. Then resultant is 100 joules only. Up to infinity also it stores the only 100 joules. If it is taken constant, if it is given constant storage. There is no any falling characteristics. If they given falling characteristics, again minus half Li square. If it is falling, minus half Li square. But no falling characteristics, constant now. That's the reason why 100 joules you have to take. Because the constant, this is 0, up to infinity it is 0. Simple, sir. If resistor is present, up to infinity means infinite joules. If the resistor is not present, up to infinity means then you have to take energy stored by the inductor initially. If it is a constant, no energy, that is 0, 0, 0, then finally you can get. Okay, like this you have to see. See the statement. Energy stored by the inductor or energy absorbed by the inductor. Energy stored means only inductor. Energy absorbed means inductor and resistor. Even though name is inductor only given, you have to take inductor and resistor. Now, can anybody answer this one? Figure shows the current flowing through an inductor of resistance 1 ohm and inductance 2 Henry. This is resistance 1 ohm, it is given. This is series. And inductance 2 Henry. Inductance 2 Henry. And this is the current. This is a common data question for 1, 2, 3. Common data question for 1, 2, 3. This is the first question, students. Determine the energy absorbed by the inductor up to the first 4 seconds. Energy absorbed by the inductor. See the statement. Energy absorbed means both resistor and up to 4 seconds it is asking. Then ER1 plus EL1. ER2 plus EL. ER2 plus EL. What is ER1? I square RT. I square RT. What is EL1? Half Li square. This is 0 to 2. This is for 0 to 2, sir. This is for 2 to 4. Okay. Half Li square. ER2. Again I square RT. EL2 is 2 to 4. It is a constant now. 0 joules. I square. 6 by root 3. Whole square. Resistance is how much? 1 ohm. Time is 2 seconds. Inductance is how much? 2 Henry. Current is 6 amperes. Half Li square. Na? I square. Constant, na? 2 to 4 constant. 6 square. R is 1 ohm into 2 plus 0. Can anybody? What is the energy absorbed by the inductor? Only 4 seconds, up to 4 seconds. What is the answer? 6 by root 2 whole square into 1 into 2. 1 by 2 into 2. 6 square plus 6 square into 1 into 2. That is 36 by 3 into 2 plus 36 plus 36 into 2, 72. That is 72 plus 36, 108. 108 plus this is 24. How many joules we are getting? This 132 joules. Is it correct? 132 joules. That is the answer. Because it's energy absorbed means you have to take the both resistor. But again, you have the doubt, sir. Here it is asking energy absorbed by the inductor, sir. But why you take a resistor also? Energy absorbed by the inductor means that inductor is having some resistance. Resistance is the part of the inductor. That is the reason. Okay. Next. Determine the energy stored by the inductor up to the first 4 seconds or up to infinity. Up to the 4 seconds or up to infinity, same here. Because energy stored by the inductor. Energy stored by the inductor is only inductor you have to take. EL1 plus EL plus and so on. Then what is the energy stored by the inductor? Half Li square. Remaining is 0. Up to infinity also it is 0. Why? It is a constant. Then half Li square. Half into inductance is how much? 2 Henry. Current is how much? 6 square. How many joules? 36 joules. That is the answer. Clear, friends? How many joules? They are getting 36 joules. Clear? Any doubt? Can anybody answer this? Determine the energy absorbed by the inductor. Energy absorbed by the inductor up to infinity. I'm expecting answer from you. No need to do any calculation. Directly answer. Energy absorbed by the inductor. Energy absorbed means both resistor and inductor. Energy absorbed means both resistor and inductor. That is ER1 plus ER2. That is ER1 plus EL1. ER2 plus EL2 plus ER3 plus EL3. EL3. Up to infinity means this we can get infinity. Then total we can get infinite joules. Energy absorbed, that is infinite joules. Up to infinity, if the resistor is present, it is infinite joules. Next. Figure shows the RC circuit and voltage V of t is applied. Determine the energy absorbed by the circuit up to the first 4 seconds. This is RC combinations. Energy absorbed by the circuit. Energy absorbed by the circuit for first 4 seconds. Energy absorbed means, yes, energy absorbed. Energy absorbed means we have to take both resistor and inductor now. ER1 plus EC1, ER2 plus EC2. Now, how you can write ER1 here? It is not a current. It is a voltage now because of parallel circuit. Then V square by R into T. Energy in terms of voltage also you know. What is EC1? Half CV square. What is ER2? V square by R into T. Because voltage is given, that's why. EC2. This is 2 to 4 seconds now. This is 0 to 1 seconds. This is for 0 to 4 seconds. Sorry, 2 to 4 seconds. This is 2 to 4 seconds now. Yes. This is 2 to 4 seconds. No, right answer. 2 to 4 seconds. EC2, 2 to 4 seconds, it's a constant. Voltage is constant, dV by dt 0. What is the dV by dt? If the dV by dt 0, what is the energy stored by capacitor? 0. This is equal to V square. That is, what is the RMS value of this? 6 by root 2, 6 by root 3 whole square by R. R is how much? 1 ohm into T, 2 seconds. Half CV square, half into capacitance value is how much? 2 farad. V square, that is 6 square. Again, don't do 6 by root 2, only resistor only is a triangular waveform, RMS value 6 by root 2. Next, V square by R into T. 2 to 4 seconds now, voltage is constant. 6 square, R is 1 ohm into 2. R is 1 ohm into, how much you can get? Can anybody? 36 by 3, that is 24, 2 to cancel. 36 plus 24, 60. 60 plus 72. 60 plus 72, is it correct? 132 joules. How much, sir? I got 132 joules. All are following or not? Is it okay? 130. It's very easy, sir. Directly you can apply. No need to do any calculations. No need to apply any derivations here. Directly you can apply 132 joules. Energy absorbed. Energy absorbed means take both resistors and capacitor. If inductors are given, inductors. Determine the energy stored by the circuit. Energy stored means you take only your capacitor is given up. You have to take only capacitor. Up to 4 seconds or up to infinity also same. Up to 4 seconds it is asked or up to infinity it is asked. It is same. Then energy stored by capacitor equal to EC1 plus EC2 and so on. EC1 plus EC2. Because constant now, remaining is constant. This is half CV square. Remaining is 0. That's why. What is E equal to? Because a constant. Half into C is 6 volts. So C is 2 farad. C is 2 farads. Voltage is that is 6 square, 36 joules. The energy stored by the capacitor is 36 joules. Clear? Next. Determine the energy absorbed by the circuit. Energy absorbed means both resistors and the capacitors up to infinity. Energy absorbed, can anybody without solving directly can answer? What's the answer? What's the answer, sir? ER1 plus EC1, ER2 plus EC2, ER3 plus EC3. What's the answer, sir? Okay, then up to infinity, energy absorbed. Energy absorbed up to infinity resistor is infinite joules now. Then final answer is infinite joules. The answer is infinite joules. Determine the energy absorbed by the circuit up to infinity, that is infinite joules. Clear? Next. This is a common data question for 7 and 8. Determine the energy stored by the circuit. Can anybody? Energy stored by the circuit. Energy stored means only capacitor. Energy stored means only capacitor. That is up to 6 seconds. Up to 6 seconds is this one. EC1 plus, EC2 plus, EC3. EC1, half CV square. Here EC1, sir. Here EC2. Here EC3. Half CV square. What EC2 is a constant now, dV by dt 0. Then EC3 minus half CV square. Why it is a falling now? It is a falling now, falling characteristic, sir. It is a falling character. Minus half CV square. This is equal to 0 joules. Clear? See, it is not a constant, but here it is a falling characteristic. Rising, falling. Then whatever the energy stored by the capacitor, that is released. Then answer is 0 joules. Clear or not? See, next. Determine the energy absorbed by the circuit. Energy absorbed by the circuit up to 6 seconds. Energy absorbed by the circuit up to 6 seconds. Energy absorbed means you have to take both resistors under. Then ER1 plus EC1. ER2 plus EC2. ER3 plus EC3. ER3 plus EC3. This is 0 to 1. This is 2 to 4. This is 4 to 6. 4 to 6. Then E equal to, what is 0 to 1, friends? Yes, half, this is a V square by R into T. Na? This is half CV square. 2 to 4, this is 2 to 4 seconds is, this is V square by R into T. This is 0, EC2 0 because constant. ER3, V square by R into T. EC3 equal to minus half CV square. Minus half CV square because it is a falling. Plus half, sorry. Plus half CV square minus half CV square is cancelled. Then what is E equal to? V square. V square means 6 by root 3. You have to substitute RMS value. R is how much? 1 ohm into T, 2 seconds. V square by R, 2 to 4, it is a constant. 6 square by 1 into 2. Next. What is the V square by R into T? Again, it is the same. This is a same value. No? This is also triangular. It's also triangular. That is 6 by root 3 whole square into R into T. T is 2 seconds. This remaining is, this is cancelled. No? This 0, then this I substituted this and this and this. How much you can get this? 72 by 3, 36, 72 by 3. Plus, this is 72. This is 72 by 3. How much you can get, friends? 72 by 3. How much? This is a 24, no? 24 plus 72 plus 24. 48 plus 72. 48 plus 72 is 120 joules. Answer is 120 joules. That is answer. If it is a inductor or capacitor, positive slope or negative slope is given, that will be cancelled. During this time, there is no energy stored because voltage is constant. Voltage is constant. Like this, you have to proceed. You try this homework for practice. Practice this. And all these you have to practice. You practice all this. Okay. You have to practice these questions. During practicing the questions, you have to any doubt. You share your doubts in my Telegram channel and I will respond. Sir, here my motive is, once I am explaining the subject, every topic I am taking, topic wise, what are the questions are framed that I am giving, what models of questions already framed and GATE ESC maximum. I am trying to give the GATE and ESC questions for both EC and EEE. Prepare the concept thoroughly, solve the previous GATE and ESC question. That is the first preference. After that, if you have the time, you have to practice some standard textbook questions. Already the standard textbooks I given, Keith and Kimberly, and one more is Alexander Sadiq. Maximum try to solve that chapter for the textbook questions you have to try to solve with this knowledge. What are the concept reality? Okay, that is the subject network theory. If you have to get more confidence, more practice is required. More and more practice. then surely you can get the confidence. This also you have to practice. And this also you have to practice. This also you have to practice. This also you have to practice. So friends, this is one topic. Up to now, I explained what are the how to calculate the energy in RLC elements, resistor, inductor, and capacitive elements. Now, how to discuss what are the different types of network elements, what exactly active and passive elements, what are the linear and non-linear elements, what are the bilateral and unilateral elements, what are the distributed and lumped elements, what are the time invariant and time varying elements. So, due to small work, I'm ending the session. Next session onwards, I will take complete 2 hours. Sorry for inconvenience. Okay. You try to practice whatever the questions that I given. For next coming class, uh, before coming to the next class, if you have any doubts, you please share your doubts in my Telegram channel. This is about the today's session. Thank you. Any doubts? Any doubts, sir? Kavya, any doubt? Apur, Abhinay, Subiksha. Any doubts? Okay, thank you. If you don't have any doubts, then I'm ending the session. Please, once again, please go through this, practice the questions, and whatever the practice I given, you solve. Thank you.